Welcome back. This is the second makeup video associated with CS 105 for week 4. So we talked in the first session about codes for professions, but that's not the only place codes come up. They certainly apply to companies as well, as in most companies have either an unspoken code of ethics or an explicit, if you work here, you shall act in the following way. My favorite code of ethics comes from Google, and their unofficial motto is, "Don't be evil." Google started out sort of touting as one of their features that they acted very much like a newspaper, and that their users relied on the integrity of their results to not be biased in any way. In their address to stockholders on initially offering Google for public stock, Larry Page and Sergey Brin said explicitly, our model is similar to a well-run newspaper where the advertisements are clear and the articles are not influenced by the advertiser's placements. We believe it's important for everyone to have access to the best information and research, not only to the information people pay for you to see. I find this very interesting because Google in 2004 is a little bit different than Google today. Last year, in May, Google decided that their Google Shopping feature, which allows folks to browse for products, will no longer be subjected to an objective search. Instead, quote, rankings will be determined primarily by which advertisers place the highest bid, though the announcement does not elaborate on what process is used for this. So you'll also notice that on standard Google searches, advertisements show up basically at the top of the page today. And that's a far cry from the Google of 5 or 6 years ago. So what is the sort of motivating factor there? Obviously there's some money involved, and that if you put advertisements at the very top on your front page, that you accept payment for ranking things higher, you stand to make a lot more money. Now whether or not this is ethical is sort of left to us to judge. And most people still find Google useful enough to use continually in our everyday practices. So until things get very much badder, we'll probably put up with such things. However, it is sort of interesting to consider us as being used as a tool for advertising consumption. Another motivating factor in talking about codes is risk. And you will all face uncertainty in your professional life, whether it's putting together a complex project, whether it's trying to understand whether an organization will support you or not as you seek to move the organization forward. And this understanding of how risk is involved is very important, and so we'll spend some time on it both in this discussion and in this coming week in the game that we'll play. So most organizations have some notion of how they handle risk, as in this company we really fly by the seat of our pants as we put products together. We're not really always certain whether things are safe or not, but as long as the customers don't complain too much, we'll be okay. This may not align with your own personal code of ethics, which we're hoping to sort of develop in this class. And ultimately, if you're working for someone that builds something, and it breaks, your company and you personally may be held accountable. So it's important to understand how your organization handles risk and what you can do to mitigate that. Now, there's a great example of risk management in your textbook. It's based on the Therac radiation machines. The Therac machines were a series of devices constructed by a Canadian manufacturer that were used to treat cancer in hospitals throughout North America. There were several iterations of this, a Therac 6 and a Therac 20. These devices seemed to work just fine. They were built by the manufacturer, distributed to hospitals, and lots of cancer was treated using them. The machine involved a combination of hardware, as in a generating device that produced X-rays and electron beams, and software that allowed a user to run the machine and put it into different modes and set different dosages of radiation in order to treat different kinds of patients. Something changed between Therac 20 and 25. If you read in your textbook carefully, they made some decisions at that point to start saving money on the hardware. In particular, they changed the hardware drastically by removing something called a hardware interlock, which I don't know exactly what the purpose of it was, but one sort of led to believe it was there for safety, maybe to prevent a certain lethal dose of radiation from ever being administered. Now, the thinking at that time was we've been using this software on Therac 6 and Therac 20, and we have not had any major problems with those versions. The software must be fairly safe. So we will reuse this same software in Therac 25. At the same time, the engineers decided to remove these safety features, and this was the cause of great damage to individuals who were being treated for cancer. So through a series of what were thought of as accidents but turned out to be major engineering gaffes, the Therac 25 machine started administering very high doses and in some cases lethal doses of radiation to patients who are being treated for cancer. This is sort of a bad engineering decision at the outset to make major changes to hardware without at least testing the software that runs the hardware. So for those of you who are going to make things involving software and hardware, changing hardware is like changing the rules of physics for the software. Things that worked when gravity is as it is right now will not work if the gravity increases or decreases tremendously. So changing hardware should involve a lot of software testing. You make changes to hardware, make sure to run through an incredibly large number of tests, especially if it's a medical device like this. There were also some subsequent mistakes. When folks at hospitals first started reporting these problems, engineers were sent out and had lots of problems reproducing the effects that the operators and the patients observed. For instance, the first team that went out was unable to reproduce the exact circumstances or behavior of the machine that burned someone so fatally that they died. A subsequent team that was sent out to investigate another burn claimed that it was impossible for the machine to administer a lethal dose of radiation. Now, if someone is sitting there with burn marks on their arm, it's sort of stupid at that point to say it's impossible for our machine to burn you. It exhibits a great deal of hubris on the part of the engineers involved. And really, you should try and avoid that kind of hubris in your own dealings, that things are always possible. They may be improbable, but when faced with direct evidence that something happened, admit that it happened and try and figure out why. Management probably should have pulled the product at that point, but instead continued to let folks at other hospitals use the machines without notifying them that there may be problems. So there's a lot of culpability and a lot of blame to be had by the engineers who worked on Therac and the management that was responsible for its continued use past the point where problems were realized. Things that you can learn as an engineer from this. Malfunction 54 was a message that occurred frequently for users of the machine. If I'm sitting there as a technician operating upon my Therac machine and I see something flash up that says malfunction 54, this is maybe cause for alarm. I pause, I look for a manual, and apparently there were not many manuals to be had for this. I worry, but eventually click the key to continue and find that nothing terribly bad happens. So the next time this happens, which is probably in the same day, I'm also slightly concerned, but less so than the first time I see malfunction 54. And as I continue to use the machine and see that malfunction 54 pops up 2 to 3 times a day, begin to be a little bit insensitive to its presence. Start to think that maybe malfunction 54 is not really a big deal at all. Until that fateful moment when I override the message, continue, and someone gets burned to death. At that point, maybe malfunction 54 carries a little more significance. The main part of this is this has absolutely no information for a user as to how bad an error is, whether malfunction 54 is a grievous error that should stop any treatment, or whether it's just informational. So as a software engineer, make sure your error messages carry some significance to the user about the whether or not it's safe to continue, particularly for a medical device like that. Also, you may want to give advisory messages of yes, safe to continue, or no, probably reboot and restart, something like that. And finally, try to deliver products that don't flash error messages like that 2 to 3 times a day, because your users will get insensitive to it and stop paying attention to them. Another critical error, the naive assumption that you could reuse software with different hardware. Make sure always to test if you do this in your own software career. That hardware changing is very, very interesting and a cause for a great deal of attention to be paid. If you read your textbook, there are several other instances, in particular the Ariane rockets produced by French folks who made the exact same mistake. New rocket, same software. Not all of the same assumptions are true as was for the previous model. Finally, the machines that are in the Theric line all had concurrency problems. Some of these were masked by the safety hardware, but that safety hardware is eventually removed from the Theric 25, which caused the buggy software to experience some race conditions. One of these was an overflow involving an integer that would get too big and flip over, and if a user hit a key at the wrong time, it could potentially cause the burn. Another one that we'll spend a little bit more time discussing involved different operators having concurrently modifying things. So we have problems as humans reasoning about this because we tend to think serially, as in one thing at a time. And if you don't believe me, try to do something simple simultaneously, like count up from 22 to 73 and count down from 150 to 98. Chances are you'll not be able to do this simultaneously, but instead we'll count up for a while and then count down for a while and then count up for a while again and count down for a while. And even that is semi-hard to keep track of. When you're dealing with software and an auxiliary machine that's taking actions, you're inherently going to deal with separate actors. I encourage you to read through your textbook description of this, but in class we did a simple simulation in which one person acted as a reader that got input from a user and would change the mode of the machine by putting cards at the front of the room. And acting concurrently were some other people who acted as benders, who would walk from the back of the room, pick up cards, return to their seats, and see if the reader was ready or not. And them sitting down in their seat with their card in hand was equivalent to the machine firing a beam. The patient would get administered either a red dose or a black dose. The correct dose for cancer being cured, and an incorrect dose being the patient was killed. If you can imagine in your head people walking up and down and you need to see where each other are, you can immediately start to recognize, oh, if someone makes a change under the hood, like as I'm walking away with my black card, this reader person puts a red card in its place, but then stands in the proper position, I could not be aware that the mode that I'm supposed to be firing in is changed and fire in the wrong mode. These are very difficult problems for us to ferret out as people. Consider this going forward, and that problem of concurrency is only going to get worse for software people. The electrical engineers have stopped making faster CPUs and started giving us more CPUs instead, and it's up to us in the software world to get them all to cooperate in a meaningful way. Lots of concurrency problems. For week 5, we'll play a game in which there will be pressure. And it's a little bit hard to understand how these Theric guys could have produced such a bad machine until you actually feel a little bit of pressure yourself, until you feel that not all the information that you need is at your disposal and that you're relying on other people to help out with a project and carry their end of things. So until then, do some reading and prepare for the game by reading about the software failures that are in your textbook.